Hello everyone, welcome to Cloudwani. My name is Mahesh and today we are going to discuss about Amazon ELB, which is also called as Elastic Load Balancing. What is Amazon ELB and what are the types of load balancers available in ELB, and especially we are going to discuss about application load balancer and its features, and also what is target group and what is path-based routing and sticky sessions, and then finally how we are going to monitor the instance health in the load balancer. And then we are going to do the same thing in the lab. So configure application load balancer and then configure EC2 and install IIS, and then configure the target groups and path-based routing, and finally also configure the instance health to make sure the instance is healthy. What is ELB? ELB is elastic load balancing and it automatically distributes the traffic across multiple targets across different availability zones. So when the traffic is coming from multiple availability zone, it will just distribute the traffic across multiple targets. And enabling the auto scaling allows you to automatically scale based on the requirement. So it also has got the auto scaling feature. As soon as we enable, it will allow you to automatically scale based on our requirement, and also detect unhealthy instances and then remove them. And also SSL offloading, especially when you're using HTTPS, the SSL offloading with AWS certificate management. You can also do it your own certificate management if it is required. What are the types of ELB? And we do have a total 4 types of load balancer as of now. One is classic load balancer, which is not mentioned here because the classic load balancer is going to retire in this August, which is August 2022. So we are not going to discuss about classic load balancer, and we are going to discuss about application load balancer, network load balancer, and gateway load balancer. And especially in this particular video, we are going to discuss about application load balancer, and network and gateway load balancers we are going to discuss in my next videos. So what is application load balancer? So this works on level layer 7 protocol, and then it will balance the load which is based on the content of the request, and it also supports traffic load balancing using HTTP and HTTPS protocols. And network load balancer works on the layer 4 protocol and able to handle millions of requests per second, and also handles unexpected spike of traffic. So when there is a huge traffic, it is going to effectively manage the traffic between the targets through the load balancer. And what is gateway load balancer? Gateway load balancer helps you to easily deploy, scale, and manage third-party virtual appliances as your targets. Application load balancer. This works at layer 7, which is application layer, and also supports session stickiness and path-based routing. What is sticky session? Sticky session is nothing like it is to enable the load balancer to bind a user session to a specific target, which means whenever the user try to connect to a session through the load balancer, it is going to use the cookies, and based on the cookies it is going to stick the session until the user end that particular session, so that it is going to make sure the user is connecting to a specific target until he ends the session. So it is going to use the cookies coming from the user session, or you can also enable the cookies or your own cookies that's going to create on the load balancer side. And what is path-based routing? Path-based routing is nothing like it is going to route the traffic based on the URL based. Let's say if I'm going to access google.com/photos, so this is going to send to a particular target where actually the particular photos is installed on or is configured on the IIS. Or at the same time, if you are going to access google.com/videos, and /videos is going to send to a different target because you configured the videos in a different EC2 instance. So it is going to separate the traffic between the targets based on the path. So you can specify, you can mention which EC2 instance to go. You don't need to mention which instance to go and which instance to access the videos or whatever it is. And supports host based routing. So host based routing is nothing like whenever user is trying to access a URL, it is going to check the URL headers or the HTTP headers to see what exactly the host they are actually connecting. Based on that, it is going to route the traffic to a particular instance. For example, I just opened my cloudwani.com website and I am going to use my developer options. So to open the developer page, and then I just see, if you see my cloudwani.com, and here you can see, you should be able to see what is the host I am trying to access. So this is HTTP header. On the HTTP headers you can see the host is cloudwani.com. So based on the whenever the request is coming as a cloudwani.com, it is going to route the traffic to a particular instance and monitor instance health using the path based file, which means you can configure a particular path to make sure the path is always available on the load balancer on the target side. So the load balancer will keep sending the health status to this particular path and to make sure the path is always available. In case the path is not available, let's say you are going to search for google.com/videos always, or every 5 seconds you are going to see this particular path is available or not. So in this case, if the path is not available, which is the google.com/videos, and it is going to show the status of the instance is unhealthy, which means you can configure an alert. The alert is going to through the CloudWatch, and then you can use the alerts configured, so you can take a appropriate action to make sure to bring back your instance to healthy. And it also supports IP based target. At the same time, it's going to support lambda functions. So whenever the request comes to the load balancer, you can also trigger a lambda function using the load balancer. And also it supports different HTTP responses. So you can make sure, let's say the HTTP header is different, and HTTP, based on the HTTP headers, you can also mention the routing path. If you see here, application load balancer is configured here, and my users are trying to access the target group, which is created in AZ1 availability zone 1, and the traffic will be routed to AZ1. And let's say if the content on all these three EC2s are same, whatever the user is accessing, it is going to send the traffic one time here, and that depends on the other time here. And you can also mention the routing policy, so based on that the traffic will be routed. So at the same time, if you are accessing the load balancer using the path based routing, let's say if you are accessing a Google/videos, and when it comes to the target site, the videos are configured only AZ1, and AZ2 there are no videos configured. So the load balancer is intelligent enough to find out where exactly the videos is configured, and it will send that particular traffic to AZ1 instances. At the same time, if you are accessing /photos, which is configured in availability zone 2, and same thing, it is not configured in AZ1, so whenever user trying to access the photos, the load balancer is going to route the traffic to /photos. In this way, you can configure the path based routing to make sure the users accessing the right instance whenever they are accessing a particular path. Now let's proceed to the lab. We are going to configure the application load balancer, and we are going to configure the EC2 instances in the different availability zones, and then we are going to install the IIS and configure a test page to make sure the path based routing is working properly based on our configuration we configured, and assign the target groups and path based routing, and then configure the instance health. Let's go back to the lab. Let's proceed to the lab. I logged into my Amazon console, AWS console, and I'm at the home page. So now I'm going to the EC2. Then I'm going to click on the load balancers, create a load balancer. So if you see here, there are three types of load balancers configured: application load balancer, network load balancer, and gateway load balancer. So I am going to select the application load balancer, create. So while creating an application load balancer, you need to provide multiple details. There, one of them is load balancer name. You can give a name, whatever the name you want to give as per your naming conventions, and then you are going to choose whether it's going to be an internet facing load balancer or internal. So when it is internet facing, so users are trying to, whoever accessing through the internet, they should be able to hit this particular load balancer. And when it is internal, only internal users who are accessing this particular application or the URLs through the load balancer will be able to access. So in this case, I'm going to choose internet facing. And you need to configure the listeners and routing. So whenever the request comes to the AT, the traffic should forward to where. So we don't have any resources specified here. So you can specify the listeners and the routing later part, but still you can also specify while creating the load balancer. So in this case, I'm going to cancel this and we are going to create an EC2 instances, and then we will come back to ALB to configure the listener ports. So let's go and create EC2 dashboards, EC2 instances. Now I'm in the EC2 dashboard, and if you see here, I have already created Zone 1C and Zone 1P EC2 instances. But still, I'm going to show you what exactly I have created so far. So I'm going to click on the launch instance, and I'm gonna choose the Windows instance for now. So Windows 2019, let's click on it, and I'm gonna choose a free type. Now I'm in the configuration settings. So you choose the VPC, on which VPC you are going to create, and you need to choose which subnet you are going to deploy. So now for this lab, we are going to deploy one EC2 in 1B and one EC2 in 1C. So let's select 1B, and remaining everything you leave default. Storage, we don't need it. And then let's go to the tags, and then configure security groups. Here we are going to allow RDP. At the same time, I'm going to allow port HTTP, which is 80, and then review and launch. So I'm gonna click launch, but now I'm not going to click because I have already created. I'm just showing you how I'm going to created the instance. And for the same second instance, there is only changes for the second instance. I only changed the subnet group where exactly I selected from a different zone, which is AZC. If you see here, one is from availability zone 1B and the other one is from 1C. So I have two virtual machines created, EC2 instances. Let's try to access one of the instance. I just logged into one of my instance, and if you see here, the availability zone which is created from 1B. So this particular EC2 instance is from 1B, and I'm going to show you how did I add the role, IIS role, which I have already added. Add roles, and then click next, and then web server IIS role, which I have already installed it. So the service is now running. So I'm going to access the default site using the local host. See, if you see, when I access the local host, so I did configure the basic HTML file, which is actually going to show us this particular VM location, which is from 1B, and it says I am from 1B. At the same time, I also configured a videos page particularly to make sure we are going to show the path based routing. So this is from 1B EC2 instance, and we do have a videos page, and in other instance 1C we are going to keep photos, so that we can make sure our load balancer is routing the traffic to a right target whenever you are accessing videos and whenever you are accessing the photos. Let's go to the second instance. I just logged into my second instance, and if you see here AP Southeast -1C, so this is from 1C zone. It's from a different zone. The previous one from 1B, and this is from 1C zone. So let's see. Here also I created a default page that's going to access localhost. If I access my localhost, it is going to show me the basic HTML page which I configured as a AP Southeast 1C, and I am from Southeast 1C. So in this particular server I also configured a photos page. So if I'm trying to access localhost.photos.png, so it is going to show the photos here. At the same time, in other EC2, which is from 1B zone, I configured videos. So I'm in the AWS console now. So I'm going to click on the load balancers. Before that, we are going to create a target group. A target group is something like you are grouping a resources or your EC2 instances, and you are making sure that whenever a particular request comes, the request is going to send to a group of instances. For example, if you see the screen, /videos is configured from 2 EC2 instances. So the load balancer can send a traffic to either one of this instance whenever user trying to access /videos. And you can also specify how much traffic EC2 1 can take and the other instance can take. So you can also mention the traffic should go either 50-50 or based on the percentage you can provide. So it's just based on how much load that your EC2 going to handle, so that you can divide the traffic between the instances configured under one TG1, the target group 1. So now I'm going to create two target groups. One is for agent 1 and one is for agent 2. In this lab, we created one EC2 in agent 1 and one EC2 in agent 2. So we don't have a third one, but still I'm going to show you how we can configure a set in a TG1 group, which is target group 1. Let's go back to the target groups and create a target group. While creating a target group, you have an options to choose the type of target, instances or the IP addresses or the lambda function or the application load balancer itself, any other application load balancer that you configured internally. So in this case, I'm going to choose instances, as we already configured a EC2 instances for this lab. Select the target group name, which is TG1, and in this case I'm going to use HTTP. I'm not going to use any HTTPS or anything. So because for HTTPS we still need to create a certificates, so I'm not doing that. So I'm going to choose HTTP and then port 80 traffic. So protocol version HTTP1. When you see here, we have a health check status. Health check status is going to check or use HTTP or HTTPS, depends on what type of protocol you are going to use. In this case, I am selecting HTTP. And health check path. So the health check path is something where the load balancer is, or the target group is going to see the file you specify here is exist on your instance or not. If the particular file you mentioned here does not exist on your particular target group or instance, it is going to show you the health status as unhealthy, so that you can take appropriate action to make sure you bring back your system online. So here, if you see here in the inetpub www root, I already configured a file name called health check. So I'm going to copy this. So I'm just paste it here, and then so it is going to see whether this file exists or not. So if we deleted this file or if the system is down, it is going to give you an alert, but you need to make sure the alerts are configured. And let's go back to the previous one once again. Healthy threshold. This is something like the number of consecutive health checks success required before considering an healthy target healthy, which means after how many attempts the health check status is done. Let's say if it is going to see the health check file for 5 times, then only it is going to make sure, or it is going to define that particular instance is healthy status. At the same time, if the instant or the target group, whenever it is checking the next 2 attempts, let's say first 5 attempts is checked and it is find the healthy file, and it is going to define as a health check is healthy. And at the same time, if it did not receive in the next 2 consecutive checkups, it is going to mark it as unhealthy, and it is going to trigger an alert based on the alerts you configured. And the timeout is for 5 seconds. Whenever there is no response, it the failed health check after 5 seconds. And appropriate amount time between health checks of an individual target. So it is just 30 seconds that you are going to maintain the interval between the health check sets of an individual target. And the success code, HTTP success code is going to be 200 always. And if the success code, based on the headers, it's going to give you the code. If let's say other than 200 if you receive, it is going to mark it as unhealthy. So for now I'm going to put it as default settings, so you can change it whenever you want. And now I created a target group, and now I'm going to assign an instance to my target group. So zone 1B instance I'm assigning in my TG1, and you need to click this particular button, which is to include as pending now, and then create target group. So the target group is now created. If you see the targets, the instance ID is defined here. So it is the health set is still showing as unused, so it is not being used so far because it is not assigned to a load balancer. So now let's go and create a load balancer. So far I never assigned a second instance, say our second target group. Let's go back to the load balancer, create a load balancer, application load balancer, app LB1, and I'm going to use internet facing IPv4. My VPC already selected, and then I'm going to choose the subnets from 1B and 1C where my actually EC2 are created. Security groups, I'm going to choose the security group, those created for my VM, where actually we allowed HTTP and the RDP ports. And listener ports. Listener ports is nothing like whenever the traffic comes from the AT, it is going to forward to a specific group, which is TG1 we just created as a target group. And you can add a one more listener. I will show you later, because so far we did not create any other target group. So and then tags, we don't need it. Let's create a load balancer, view load balancer. It is now provisioning. So meanwhile, let's go and create a second target group. I'm going to create another target group using the instances, and then same protocol HTTP health check status. Again I'm going to put health check file which I have created in my instance. Then next TG2, which is target group 2. Next I'm going to choose the second instance, which is zone 1C. It is created in Southeast 1C, and selecting, then create a target group. I have 2 targets groups created now. Let's go back to the load balancer, which is still provisioning. Let's wait for some time. Meanwhile, we can just try to copy the DNS name. So the ALB is now creating. When you go to the description, you can see the name app LB, which we have given, ARN, which is automatic resource number, which is going to be unique, and at the same time the DNS name you can see, and the state is provisioning, type application, and scheme, which is actually internet facing, and the IP address IPv4 we are using, and the VPC and the availability zones we specified. And when we go to the attributes, we can also see deletion protection is disabled, because when you put the deletion protection, it is not going to allow you to delete unless you allowed particularly. And ideal timeout is 60 seconds. So ideal timeout is nothing like whenever a session established through a load balancer, it is going to clear that particular session only after 60 seconds. And then HTTP2, the version we enable. Desync mitigation mode. Desync mitigation mode is something whenever the HTTP address are coming as a null, it is going to take a appropriate action that we specified here. So here it is specified as defensive mode. So when it is compliant, actually that it is going to allow, when it is acceptable also allow, and when it is ambitious also allowed. When it is going to be a severe mode, it is going to be block the traffic. And drop invalid header fields. So whenever the header fields are invalid, it is going to drop, which we disable now. So we can use this for security purpose. And access logs is disabled. You can enable the access logs to CloudWatch. And WAF file open is disabled, so we are not using WAF file. So let's close this. And we do have a TLS version and cipher address. Because we are not using the HTTPS, we are not going to enable this. And client port preservation. So this means that the source IP address of the original client is preserved for packet that arrives at the load balancer. So as of now, we are not going to preserve the IP client IP, so we just disable this. Let's refresh and see what is the status of our load balancer. Is now active. Let's copy the DNS name and try to access from a web browser. So I'm going to use this AP Southeast 1B. So we will be always getting 1B because if you see the target groups, we assigned so far only one. So there are no other, the second target group is never assigned. It is going to show you as unused. So now we are going to assign the target group 2. However, when you are assigning a target group 2, just go back to the load balancer and listeners, and in the listeners you do see HTTP 80. So but the listeners can be only be one port, so only one time we can assign. So you cannot add another listener with the same port. So in this case, we are going to edit the same existing listener, and then we are going to add a target group here, which is TG2. And if you see here, weight is 02999, and we have specified here is 1 and here is 1. And let's say if I'm going to put this 0, it is whenever the traffic comes, the 100% traffic will go to the TG1. But if you put 1 here also, the traffic will be divided into 50% here and 50% here, if you are going to access the path which is available from the both target groups. So here I'm going to put 1 and 1 for this particular lab, and here you can enable the stickiness. I'm not going to use stickiness here. I'm just going to disable. When you, as we discussed, stickiness is going to keep the session live until the user disconnected it. So it is going to use the cookies to configure the sticky sessions. Let's save the changes. And now if you see the listeners, view or edit, I do have a 2 listeners the configured here. So what are the policies? Edit rule. So if you see the request otherwise not routed, which means whenever the request comes to this particular listener, it is going to send the route the traffic to TG1, which means if none of the other TG groups or the target groups is not received the same request, then only it is going to forward the traffic to these particular groups. Let's edit the rules, edit, and then I'm going to add a new rule. The rule is going to be add condition. The condition is whether host header is same or the path or the HTTP header or the query or query string or source IP. So we do have a multiple selections where you can create a rule. So if the host header is this, you can just forward to the other one, or if it is the path is same, or you can give a path and slash videos or whatever it is. You can then add a selection and then forward to tg1 or tg2. So in this case I'm not going to create a rule because I have already have a default rule, and also I don't have any multiple rules here. So if you do have any multiple rules, then you can specify a particular rule saying that this particular rule or this particular path should route the traffic to tg1 or tg2. At the same time, you can create a host headers rules or the other rules which we have just seen here. Let's cancel this, and now go back to my load balancer, and I have assigned the both targets now to my load balancer. Let's try to access the DNS. So I'm going to paste my DNS here again. So now if you see 1B, let's try to refresh the page. If you see, every time I refresh it is going to change. So 1C sometimes and 1B sometimes and 1C sometimes and 1B sometimes. So the load balancer is now sending the traffic to multiple instances whenever we are trying to access the DNS. However, let's try to access a particular page that we had created earlier. So slash, I'm going to access the videos with the same DNS name, which is my load balancer name, but I did change the path to videos. So videos.png, if you see, whenever I am accessing videos.png followed by my DNS name of the load balancer, it is going to take me to a instances where exactly I created in only one server. At the same time, I am going to use photos.png. The traffic is now routed to a different host, which is my second EC2 instance created in a different zone. So the load balancer is actually intelligent enough to route the traffic between the instances based on the path you have given while accessing the URL. This is my first instance, and if you see, this is from 1C, and in 1C I created only photos and there is no videos file here. And when I come to my 1B instance, I created only videos. So the traffic, whenever you are accessing the videos, it is coming to here to load balancer, and whenever you are accessing the photos, the traffic is routing to other instance. As you see here, the target groups, when we go to click on target group and health status, we define that healthcheck.html, and if this file is exist, the target group status is going to be healthy status. Since the file is already exists in our server, it is going to see the healthy status of this particular target group instances are healthy. At the same time, let's go to target 2 is also healthy. So if you see my instance here, I do have a healthcheck.html page file already created. That's the reason it is showing the health status is healthy. So at the same time, I'm gonna access my healthcheck.html page. If you see, it is health check status okay, and I am from 1B. And let's try to refresh. And if I refresh, the traffic is rerouting to another one instance, and now it is showing as 1C here. So this is how we can define or we can monitor the particular instance health or the target group health status. And when you enable the access logs, you can configure the CloudWatch alerts to make sure there is an alert triggered whenever the health status of this particular instance is changed to unhealthy. So as we just configured, the users are trying to access the page of /videos, the traffic is routing to AZ1 EC2 instance. At the same time, whenever they're trying to access the photos, the traffic is rerouting to AZ2 instances. And if the user is trying to access a common URL, sometimes it is going to send to AZ1 and sometimes it is going to send it to AZ2. You can specify how long the connection stay on the particular instance or the particular target group, to say that this particular session can stay in this particular target group for a while, or 10 seconds or 20 seconds, then it can change to AZ2. So this is just to make sure there is a proper connection established for a time being, and it serves a request based on the user sent. With this, we completed the application load balancer configuration, and so far we configured the EC2 instances and then configured the IIS with different regions from the different regions, and then we configured the target groups, and then we added the EC2 instances to the target group, and then we try to configure the application load balancer, and we try to access the web pages or the web URLs from the application load balancer that was configured. And also we configured the health check status of the instances based on the path we have given, or we have given in the health check status. So as soon as the file is available, the health check status of this particular instances or the target group will show it as a healthy, and as soon as we rename or remove that particular file, the health check status is going to be unhealthy, and you can take an appropriate action as soon as you have been informed about the alert. That's all for now. Thank you so much, and I hope you enjoyed my video, and please help to subscribe my channel for any further updates. Thanks a lot. Bye bye.